Inverse distance weighted interpolation is one of the most common interpolation methods that you will find. You find it in your geoprocessing tools. Simply type in IDW. You'll see it's actually located in multiple locations under 3D Analyst, Geostatistical Analyst, Spatial Analyst. They all do the same thing. You simply select one and then give the software the instructions of which values to use for interpolation. In this particular instance, I have chosen to use my point input layer, the relief points. You can just drag it in, or you can of course select from the suitable ones. It has to be a point input layer. This is the difference to QGIS, where you can actually interpolate to IDW from line features as well. In Pro, you are restricted to point features. If you want to interpolate from line and point features, I suggest you use the Topo to Raster tool. The Z value is your height value. In this instance, this point layer has the height values, the Z value stored under the height attribute. You could also simply have looked at the attribute table, and you would have seen that here is the height information. So this particular point has a height value of 1,034 meters in this instance. And you can see the point highlighted there. So you select the Z value as the height value you want to interpolate from. My point layer is in elevation, so this is an actual height value, meters above sea level. However, you can interpolate any value that's a continuous field. It doesn't have to be elevation only. You can interpolate rainfall values, temperature values, soil quality values, anything that is continuous in nature. And then that Z value would be that attribute that reflects that value that you want to interpolate to. You have to give it a name, of course. So in this case, I'm saving it as a TIFF file. You can also save it in a geodatabase. If it's outside of a geodatabase, ensure you give it the extension that it requires. In this case, it's a TIFF. You also determine the output cell size. This is a user input, but there's always a default value as well. The default value is calculated based on the spatial extent of the points in the image, as you can see here. I have given it an output value of 30, so my cell size will be a 30 by 30 meter cell, so 900 square meter area. And then I can have additional values that I can adapt. So you've got my power function to what is the distance between my points going to be taken. The higher this number, the greater the weight is given to those input values that are closer to the one that I'm estimating. Also, I can choose between variable and fixed interpolation. Variable interpolation means I have to specify the number of points that will become part of my IDW interpolation equation. I will always use 12 neighbors to interpolate an unknown value. If I choose fixed, I have to specify the distance that my radius is willing to go. So in this instance, it's 150 meters. I can change this to anything that I would like. It's in the units of your data set. So this is, with me, a planar projection, hence it's in meters. And this would then be 1 kilometer. So depending on your specifications, variable focuses on the number of neighbors it will consider in my calculation, and fixed, how far I need to look each time, and everything in that radius will be considered part of my interpolation equation. I can also specify minimum points to specify the minimum number of points that should always be in my calculation. And then I can also put in a barrier. This would be, for example, important when you have a cliff face where there's an abrupt change in drop, where you shouldn't really extend in the data set across the cliff face because it should stop there. If that barrier is in place, the interpolation equation will not consider anything beyond that barrier line. So in this case, I'm doing a variable interpolation of 12 input points, and I simply say run, and your output will look like that, with your height values indicated in your legends. If I were to do this using a fixed interpolation, let's say of 1,000 meters or 500 meters, and I run it, you simply say run, then the outputs that you get will reflect the interpolation based only on that 500 meter radius, not the number of input neighbors that you have in your interpolation. as you can see here, because you're using a very small radius, you do have a full coverage across the entire surface, simply because the number of input points was not sufficient for these values in these empty spaces to exist. That is an indication that you should have a much larger radius. So for example, you run the 5,000 meter radius. In this case, you'll see that you have a much greater coverage of the surface that you're interpolating based on that. And here we are with a 5,000 meter radius. As you can see, good coverage all across, none of those empty spaces, the null values that were present when the radius was too small.